This next video will show how to actually go about processing and thinking about the different chemical equations that can be used when talking about a precipitation reaction. So this right here is the molecular equation. I've been calling this the balanced chemical equation. And notice that it is currently balanced. It's got reactants on this side, products on this side. Remember though, however, that these reactants, if we're talking about aqueous solutions of these reactants or these products, aqueous solution of these products, in reality we're talking about these ions being dissociated in water. And so a more accurate depiction of what's going on in solution is shown below. Silver ions plus nitrate ions plus potassium ions plus chlorine ions react to form silver chloride solid plus potassium aqueous and plus nitrate aqueous. So potassium ions and nitrate ions. This right here is shown as the complete ion. What I'm showing is the complete ionic equation, and it shows all electrolytes, okay, broken apart, dissociated, all strong electrolytes dissociated into their ionic characters, okay? So they're ionic species, okay? So it's all dissociated. The only thing that's not dissociated is this solid product. Notice that everything up here that's aqueous, that's shown in the molecular equation, is broken apart into its ionic portions down here. Notice also that we still have the state of matter shown for the complete ionic equation. So there are a couple more equations that are important here. One of them is the net ionic equation. So the net ionic equation looks a lot like the complete ionic equation, except what we do is we cross out any ions that have not changed from left-hand side to the right-hand side. Remember that I showed this a little while earlier. So so things that have not changed from left-hand side to the right-hand side are being crossed out, and the result, what's left over, is the net ionic equation. So we have Ag plus Cl minus going to form AgCl. The things that have been crossed out are what we call spectator ions. So the nitrate, potassium are the same as the nitrate and potassium on the reactant and product side. So we see these two species not having changed from the reactant side to the product side, and so we consider them spectators. So the steps for writing these reactions, a net ionic equation, is first you have to balance the molecular equation. That is the balanced chemical equation. That's shown right here in step 1. Of course, this one's already balanced, so there's no 2's or coefficients that we need to add here. Step 2, you break apart all strong electrolytes. So anything that is in aqueous form, you break it apart. Ag plus, NO3 minus, K plus, Cl minus. On this side we have AgCl, but it's solid, so it stays together. And then K plus and NO3 minus, shown as aqueous up here. Next step is you cross out anything that remains unchanged from the left-hand side to the right-hand side. And then finally you write what's left over that has not been crossed out in step 3. So there's your net ionic equation. So whenever you're going about writing or asked to write a net ionic equation, follow these steps right here, and it'll bring you to your answer.